All right, today we are going to do reflections on a coordinate plane. So first, let's remember what a reflection is. It's a transformation in which a geometric figure is reflected across a line. It creates a mirror image called a line of reflection. Okay, remember the word reflection is a flip. So today we'll be performing some reflections on a coordinate plane. The x and y axis will be our lines of reflection, so we don't need to get a ruler out because we'll just be counting the spaces. Okay, we're going to reflect this object below over the x-axis. So the first thing we're going to do is name the coordinates of the object. This is a quadrilateral, so there are 4 sides and 4 vertices. First, vertex A. Remember, we start at the origin, and like a ladder, we go left to right first to -5, and then we climb at 8. B, we start here, we go -6, up 2. C, we go +6, then up 5. And then D, we go -2, and then 5. Okay, so that is our original shape, original figure. Now to reflect it over that x-axis, we're going to take A, and we're going to move it down 8 spots to the x-axis, our line of reflection. Then we're going to move it down 8 more. Put a point there. That's A prime. For B, we're going to move it down 2 more, B prime. C, move it down 5 more, C prime. D, down 4 more, D prime. Then we'll connect our dots. We should have a congruent shape, a congruent geometric figure, just flipped over that. Okay, so now let's name the coordinates of our reflected object, starting with A. Still -5, but then -8. Still -6 for B, then -2. For C, still 6, but now -5. And for D, still -2, but then -4. So let's compare these. First, compare your x. What happened to the x coordinate? Yeah, they stayed the same. What happened to the y coordinates? They all became negatives, right? So if it was negative to start, you think it'd stay a negative? No, it'd be a positive. So it became its opposite. Opposites are 2 numbers that are the same distance from 0 on a number line. So what did you learn? When points are reflected over the x-axis, the x-coordinate stays the same. It's the y-coordinate that becomes the opposite. Okay, let's reflect an image over the y-axis now. Okay, so T here is 9, 8. J, 9, 3. And then Y, 1, 1. Okay, reflect it over the Y. So T, we got to move it over 9 to -9. T prime. J, got to move it over 9 to -9. J prime. Y, move it over 1 to -1. Y prime. Connect your dots. They are mirror images of each other. So now, the last one, when we flipped it over the x, we changed the y. Now that we flip it over the y, what do you think we'll do? You're right, we change the x. All of these will become negatives. All of these y's will stay the same. Why is that? Well, T was at +9. Now it's at -9. But it's still 8 up. Okay, so what did you learn? When you reflect over the y-axis, the x-coordinate's the opposite. Y-coordinate stays the same. Let's see if we reflect over the x and then the y. Okay, so we're reflecting over the x first, then the y. So our original coordinates, negative 9, 9, negative 8, 5, negative 2, 4, and negative 9, 2. We flip them all over. We connect our dots. Okay, now we're going to flip it over the y-axis. U becomes U double prime, P double prime, R double prime, and D double prime. Look what it looks like now. It was like this. Now it looks like this. Interesting. Let's look at what our final coordinates will be. So R is now 9, negative 9. Ooh, look at that. They both became opposites. P is 8, negative 5. The opposite of both of them. D is 2, negative 4. Again, both became opposites. And U, negative 9, 2. The opposites of both coordinates. So how were the coordinates affected when the object was reflected over both the x-axis and the y-axis? They both became opposites. Do you think it would matter if we flipped over the y-axis first and then the x-axis? Would it put it at the same spot? Yeah, it actually would. Okay, so let's use a pencil to plot the reflection point A across the x-axis. So here it is. Here's the x-axis. We're going to go up 1, 2, 3, and then up 1, 2, 3. I'll try to do it with my pen here. So we're 3 away, and then 3 more. Puts our point here. The point was at negative 6, negative 3. Now the point, now that I've flipped it over the x-axis, it's my y that should change. Now it should be at negative 6, positive 3, which it is. Don't forget to close your parentheses here. Anytime we have coordinates, we gotta close them. Okay, the point A is shown here. Reflect over the x-axis, then the y-axis. Okay, it is right now 7 above, so we're going to put it 7 below. So there's A prime. And then it was 6 to the right, so now we're going to put it over 6 to the left. So here's A double prime. Here's my answer. So we should find the opposite x and the opposite y. So instead of at 6, 7, it should be negative 6, negative 7. Okay, now we're going to move the whole thing. First reflected over the x-axis. Well, first let's find the point. So the point is negative 7, 5. If we reflect it over the x, it's the y that should change. It should be at negative 7, negative 5 now. Let's see if that happens. So we're reflecting over the x here. So we're bringing it down 5 from the positive to 5 to the negative. Yes, sir, that's negative 7, negative 5. Okay. If you have Alex, you have lots of transformation topics you could do. You could translate. We can reflect today. A lot of good things to do here. Good work today.